with setting up the... I told you I had a rogue panel. They won't even use this computer. Barak Morgan is an engineer, a scientist, a medical doctor, and he brings new ways, fresh ways of thinking to try to help understand what Mark described as the phenomenally difficult task of trying to shift behavior. So what Barak is going to be speaking about is trying to kind of unpack a theory of change for the first 1,000 days, the emphasis on relationships, and helping us to understand why behavior change is so difficult and how we can be more effective in bringing that about.
Thanks, Anna. Well, it's not there, so I have to stand here, so I'll use this. Hello, everybody. It's great to be here. I want to thank Anne-Marie for inviting me and for involving me in the first 1,000 days process. Yeah, what comes to mind is something that Woody Allen said once, and that was that he's not sure what the question is, but sex is definitely the answer. So I'm not sure what we're trying to change, but at least we have a theory. And compared to Hillary's fantastically detailed slide, I've pared it down to 3 words. Relationships matter most. And yeah, so what I'm going to talk about, why I say I'm not quite sure what we're trying to change, is just that some of the frameworks that we have been using for a long time, the science is actually showing us that perhaps we need to go further. So another title for this talk is Beyond Toxic Stress. So what can developmental neuroscience do to provide us with a theory of change? What's basically happened in the last 20 years is the relationship between brain, mind, and behavior has just become incredibly well understood. The detail that we can now dissect these relationships with is truly astonishing. And because what happens in the mind, feelings and thoughts, and what happens in behavior all comes out of the brain, the way the brain comes to be the way it is of the utmost importance. So we used to ask about nature or nurture. So now I'm going to do what Mark asked me to do and show you some data from the Tulasana study, where we followed up the children at 13 years of age, just to show you that nature, in other words, genetics, really matters. So what we see here on the extreme right-hand side are the original results Mark found, that the intervention study, the incidence of secure attachment, was significantly higher than in the control group. 75% versus 65% of the infants were securely attached at 18 months after the original home visiting intervention started in the 3rd trimester. At 13 years of age, we took saliva from which we extracted DNA, and we looked at a particular gene, the serotonin transporter molecule, which comes in a short form and a long form. And what we found is that the entire effect that Mark found at 18 months was driven by children with a short form, so the first 2 columns. Children with at least one short allele, shown there as S, who received the intervention, in that group 84% of them were securely attached, compared to those who didn't receive the intervention, only 58% were attached. For children who had the long form, shown in the central columns, the intervention made absolutely no difference. The incidence of secure attachment at 18 months was 70% versus 71%. So this is just an example of how we can drill down into the biology to understand something at the behavioral level and the mental level with extreme precision. And it raises all sorts of complex questions about the use of resources. In other words, spending a lot of money to deliver an intervention that has no effect on 60% of the children. In other words, those children with the long form, they were 60% of the population. On the other hand, intervention has a massive effect on the children with the short form. So that's just something to think about. Okay, nurture also matters. This is data from the Bucharest Early Intervention Study. Romanian children who were severely deprived, institutionalized, were adopted into Canadian homes. And when they were 8 years old, social skills were compared between those who were adopted and those who remained in the orphanages. Now, amongst those who were adopted before 20 months of age did as well, it was not significantly different, to their Canadian peers. That's the two right-hand bars. Those who were adopted into foster homes in Canada after 20 months, they did no better than their peers who remained in the orphanage. So nurture makes a big difference, but it also depends on when. And so 20 months seems to be a critical cutoff for sensitive period, and clearly that falls well within the first 1,000 days. So now we can actually understand how nature and nurture work together. And what's really made all the difference is epigenetics. Epigenetics is where the genes and the environment ultimately meet, where they physically come together. And the early environment programs gene activity with long-term consequences for brain architecture. And after the early years, it becomes increasingly difficult to change brain architecture. This graph shows how brain plasticity falls off rapidly with age, and how the effort needed to change the brain increases rapidly with age. Now let's look at this in some more detail. How does the environment influence brain development and brain architecture? So all the time, the thing the brain is always asking itself is, am I safe? This is a fundamental issue for survival, and therefore a large part of the brain is devoted to this question. When the brain occupies a bountiful, safe and predictable environment, a favorable environment, then basically the prefrontal cortex, which is the top of the brain, switches off the amygdala, which is at the bottom of the brain. The amygdala being this part of the brain that's responsible for asking the question, am I safe? And is on a hair trigger ready to say, to respond to that with a fight, flight, freeze response. So under these conditions, safe conditions, the cortex is dominant, it can downregulate the subcortex, it can get on with the things the cortex is good at doing, which is thinking, planning, creating, and you end up with top-down brain architecture when you grow up in a safe environment. And you become a kind of a brain, kind of a person who thinks first and acts later. You can keep your head, you can thrive because you've got the big picture. In contrast, in harsh, unsafe, unpredictable environments, the opposite happens. The amygdala takes control, the subcortex, the bottom of the brain, and it literally switches off the cortex. You can't do any of those things, and you end up with bottom-up brain architecture, where you tend to act first and think later. You lose your head, but you survive. The bottom brain, the subcortex, it knows how to survive, and it takes over. It tells the cortex, hang on, I'm taking over now. Things are not safe. So let's look at this in terms of parenting, stress, and brain architecture. What makes me feel safe? Got those the wrong way around. Relationships. They matter most. In fact, they matter most because the only thing that can make the brain feel safe are caring relationships. So we've spoken about stress, and essentially there's positive stress where the stress response is activated, you get increases in hormone levels, but they're not very they're not very big increases. You then get tolerable stress. Where there's a severe stressor, you get large increases in the stress response, in the hormones. But if the situation is buffered, by which we mean, in a case of a child, if there's a parent there or a caregiver who can hold the child, who can reassure the child, who can be the cortex for the child can't see the big picture. There's a loud noise, its nappy's wet, thinks it's the end of the world. Stress hormones go into overdrive. But if there's a caregiver there to buffer the situation, calm the child down, the child's subcortex stress response will come down. Toxic stress is when that doesn't happen, when there isn't buffering and the stress systems are activated and they go super high and they don't switch off for a long time. Okay. Now what's all this got to do with epigenetics? So here's a diagram of the hypothalamus, pituitary, adrenal axis, one of the main stress response systems in the body, and it is under the control of the hippocampus, which is part of the cortex. It's ancient cortex, but nonetheless it's cortex. It's the top brain. Now what happens is when the adrenal gland is stimulated by a stressor via the amygdala to release cortisol, which is a stress hormone, that cortisol goes back to the hippocampus, and those little blue and white V's are the glucocorticoid receptors. And the cortisol docks into those receptors, and that tells the hippocampus to tell the hypothalamus to switch off the stress response. Now, when there's good buffering, the brain develops in a way that there are lots of those receptors in the hippocampus, so that the negative feedback works very well, and the stress response can be switched off. So strong buffering in early life leads to long-term epigenetic programming, because the expression of those receptors is under epigenetic control, and the amount of care, the amount of love, the amount of buffering that the child receives in early life epigenetically programs the density of those receptors in the hippocampus for life. Remember that 20-month cutoff? So things happen early on. This is why they happen early on, and they can't be changed. When you don't get enough buffering, when you don't get enough love and assurance and protection, you get fewer of those receptors. Cortisol negative feedback cycle doesn't work very well, and you end up having toxic stress. Okay. And this was studied very carefully in mice, but exactly the same thing was shown to happen in humans. Glucocorticoid receptor in the human brain was shown to be epigenetically regulated in the study of childhood abuse. So here's some data, again from a study I did with Mark, the Tulasana study, where we looked at cortisol response to a public speaking task. We gave these adolescents a task to deliver a speech to an audience, which is very stressful. And what we found is that those whose mothers were rated to be sensitive at 6 months of age, so that's 13 years before, their stress response, their cortisol, we measured cortisol from before the speech to during the speech to afterwards. They're the blue line. It went up, but it came down. Those whose mothers were rated to be low in sensitivity at 6 months, you can see that their cortisol response was much higher and it took longer to come down. So once again, 6 months of age measures something 13 years later. This is what the epigenetic programming does. So we would say that these have got a top-down brain versus a bottom-up brain. All right. So now let's look at poverty. Here's a study which looked at executive function at 4 years of age, plotted against number of years spent in poverty, and the more years in poverty, the poorer executive function. Prefrontal cortex, in other words, function, was poorer. I've got 1 minute, I'm going to have to race. The thing is now, is it really about poverty? Here we got some studies look at hippocampus volume and in relation to maternal support, and basically the more maternal support, the bigger the hippocampal volume. Here we look at working memory in relation to maternal responsiveness. Green arrow, if you have a mother who is responsive and you undergo high stress, working memory doesn't suffer. If you don't have a maternal responsiveness, highly responsive mother, working memory suffers. The point here being that it's not poverty per se, it's the toxic stress. That's the problem. And as I said, the only thing that can alleviate toxic stress is that caring relationship. And that's why in the position paper you see all those words, love, protection, safety, and so on. And the wonderful thing about the neuroscience is it joins those words to brain architecture and to all the things that we are concerned about. So here's a situation of South Africa showing loss of development potential in relation to some other countries. And the x-axis is poverty. But what we've seen is that it's not really poverty, it's toxic stress. And so our theory of change is based around what makes me feel safe, and the only thing that can do that are these caring, supportive relationships. And if we want to get South Africa down that graph, because we have all these environments in South Africa, so if we want to shift everybody down the graph, we have to reduce toxic stress, and that will move us down the graph. The only way we can do that is to improve relationships. And relationships are not just between the parent and the child, or the caregiver and the child, but everyone is responsible for building children's brains. It's not just neurons to neighborhoods, it's neurons to nations. And that's why I want to applaud the Western Cape, who I can't teach them anything. They've already got it with their all-of-society approach, which we saw beautifully presented earlier. Thank you very much.